Right, so what I have to prove here is that when you have two triangles with a similar base and the same perpendicular height, then you'll always get the same area. This is because if I draw a triangle here, I'll show you. So I have one triangle here in brown, and I'm just gonna bring the vertical height across, and I'll draw a red triangle as well. Now, as you can see down here, X, they have a similar base, as well as the line from brown to blue being common in both. It shows that they both have the same perpendicular height. So what I'm going to do now is to show that the formula for a triangle is half the base by the perpendicular height. So I'm just trying a perpendicular height here. So that's my perpendicular height there in green, so I'm going to call that Y. So we know that the area of a triangle is equal to half the base by the perpendicular height. So half of X by Y. And how we know this is by the way we know that the area of a parallelogram is the base by the perpendicular height, and that gives you the area. And whenever we draw a parallelogram, we have the sliding set squares. So as you can see, there's my parallelogram now for the red triangle. So from this point, 1 to 2 to 3 over to 4, so that we know that the area of this parallelogram is the base by the perpendicular height. And as we can see, two triangles fit into this base. Triangle 1, 1, 2, 3, and triangle 2 is 1, 3, 4. And for this, we know that these have a common area. So that's how we know that the area of a triangle is half the base by the perpendicular height, because it's half the base of the parallelogram, which is the base by the height. So if you just write that mathematically, you'll see that the area of a triangle is up here, is half the base by the perpendicular height, and the area of a parallelogram is equal to the base by the perpendicular height. And since two triangles can fit into the parallelogram, then the area of the triangle is this over 2, which is equal to half the base by the perpendicular height, which can also be said as half the perpendicular height by the base, as it doesn't matter once they're all multiplying each other. So the formula we're trying to prove is that if two triangles have a same base and a common perpendicular height, then they'll have the same area. So if we go back to our first triangle, which is 1, which call this 5, 1, 5, 2, and we create a parallelogram for this, so the parallelogram here is 1, 2, 5, 6. So then, as you can see, the triangle 152 is half the parallelogram 1526. So therefore we can get that half the area of the parallelogram is equal to the area of the triangle, and since the area of the two parallelograms is equal to x by y, which is the base by the perpendicular height, then therefore we can find out that both triangles 152 and 123 have equal area due to this matter. So I'll just write it out so it's easier to understand. So the area of parallelogram 1265 is equal to x by y. The same area of the parallelogram 1, 2, 3, 4 is equal to xy. And since we know the triangle, the area of the triangle 1, 2, 3 is equal to half x by y, then the area of the triangle 1, 2, 5 is equal to half x by y, as these are linked and these two are linked. Therefore we can show that since the triangles 1, 2 and 3 and the triangle 1, 2, 5 have a similar base and the same perpendicular height, then they have the same ratio, which means that it's common throughout. Thanks.